Okay, I hope you enjoyed that. Christopher Cross, Ride Like the Wind. I'll tell you what, he came out with that album, I don't know, right around 1980, something like that. Every song on that album was an instant hit. Of course, he didn't really make much more music after that. Christopher Cross was really known as a guy that worked in studios, and he was a backup singer for lots of other albums, CDs and stuff, songs that were written and produced by other artists. He went on his own. He had that one great big hit. Not too much after that, though. All right. Well, you can tell from the song we're going to talk about wind energy, and it is the most rapidly growing source of electricity. You can see here the statistics. Whether we look at the capacity of wind, or we look at the percentage of electricity by wind, it's a big deal. Now here in the United States, we only get about 1% of our electricity from wind. So it's a small percentage of the total, but let's face it, wind is up and coming. It has considerable advantages for us here in the United States, and it's widely used around the world. Of course, once again, we make the argument that wind energy is really solar, because wind is caused by the uneven heating of the Earth's surface. You need to remember that. That's where wind comes from. The winds that we have here happen because of the uneven heating of the Earth's surface. And what heats the Earth's surface? Sun, 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 here it comes. So, you can make the case that wind energy is really solar. Okay, let's see what the capacities are in other countries. Take a look at these graphs real quick. First of all, we have the United States is number one when it comes to actually producing energy from wind. And here's Denmark. They're also on the list. And let me find the page for you that this is on so that you can follow along. It's on page 363. But as a percentage of their electricity, remember, we're only about 1%. Denmark, almost a little over 20% of Denmark's energy is from wind. Well, that shouldn't surprise you. They've been famous for their windmills for a long period of time now. And you can see the other countries. Point is, wind is up and coming and could be a valuable way for us to get electricity. Once again, it's got its negatives. Here's how it works. And isn't this an eyesore? Wouldn't you hate to go to the beach and see something like that sitting off the coast? But the fact is that it's always windy at the beach. And so why not take advantage of all of the wind that comes off the oceans and spin a turbine? And that's what happens. This diagram shows you how it works. Very simple. Even simpler than a power plant that burns coal, because all you have to do is use the wind to turn the turbine that turns a ball of wire inside a magnet, and electrons will flow down the shaft on a wire. And every one of these things obviously has to be connected to the grid somewhere back on land. Who knows, it might be way over here somewhere. But somewhere on land, these windmills have to be connected to a wire that makes electrons go, and then they can add their electrons to the grid. Very simple design, works pretty good. And I'm sure that you're aware, but engineers have figured out that this three-pronged blade is the right way to go. Not 4 or 5 like we have the fans in our house. This is the best way to capture the the wind caused by uneven heating of the Earth's surface. This line graph here just shows you how high, this is in gigawatts. That's a lot of watts, and just shows you, how high over the years solar energy has become. Very popular renewable resource. As long as there's a sun, there will be wind. Now, experts say that we have 100% of our electricity needs could be accommodated by the winds that we have here in the United States. Of course, we're not going to come anywhere close to that because wind is not sustained. There's going to be times when this fan blade is not blowing. If it's not windy today, you're not going to be happy with not having electricity. So wind will never be 100% of our energy needs, but if you measure it just in terms of gigawatts and all of the potential of all of these turbines to spin, we would theoretically have enough wind energy to turn, to provide all of the electricity in our country. A typical wind turbine could produce enough electricity, to provide enough electricity, for instance, for 400 homes in the course of a year. Remember, it's not going to provide that every single minute of the day because it's not spinning every single minute of the day. And that's why you will always find these wind turbines in groups. Gotta have a lot of them. Anyway, you can see where we have our maximum winds. It's the purple area. Our maximum winds, of course, are on the Great Lakes. Here's Lake Ontario, my Great Lake, where I went to. This is Lake Ontario, my Great Lake. There's Michigan, Superior. Anyway, lots of wind in the western states. Lots of wind here in California and Nevada. So it shouldn't surprise you that this is where the wind projects are. And there are more to come. Look at how invested these states are becoming in wind power. It's becoming more and more popular, as I stated. There are advantages and disadvantages with wind. You need to be familiar with them. I want to go over the disadvantages first because I want you to understand them. They're very important. First of all, they are not a steady form of electricity. If it's not windy, there are no blades turning, no electrons running on a wire, and that means you're not getting any power to your house. Certainly, though, they can provide lots of electrons. Even when the electrons are not needed, those electrons can go to a battery somewhere, and they can at least charge a battery, and we can store some of the energy that way. So backup systems are needed. Here's one of the major disadvantages. It takes up a lot of land. Talk about habitat destruction. This was once woods or something. We have to cut down the trees and we have to put up the wind turbines. By the way, I wanted to mention something while I'm thinking about it concerning California. You know that they have a different coastline from us. Their coastline has a lot of cliffs and bluffs on it. So you have to do some considerable climbing down if you want to go to the beach in California. Well, guess what's up on top of those cliffs and mountains? Lots of ocean blowing wind. So you will oftentimes see these big wind farms, like the one depicted here, up on top of the big cliffs of the ocean. And that provides a lot of electricity. Still, we have a lot of land use associated with it. Now, that problem can be mitigated. It can be mitigated by farming. This term wind farm means just a land area that's got lots of wind turbines on it. But we can literally graze cows. Moo. Moo. We can graze cows on the land underneath the wind turbines. Are we going to put houses on this land? No. Because guess what? Wind turbines are noisy. Not one, not two, but when you literally have hundreds of them lined up, as you see in the diagrams, they are noisy. So you're not going to want to live anywhere near a place that has a wind farm. So here are the major ones. You know, visual pollution, yeah, people don't like to see them. I get that. But hey, if that's the only way you could get your electricity, you'd live with it if you had to. But these are the big ones. High land use equals habitat destruction. Lots of noise. And here's the other big one you don't hear a lot about. I don't even know if this is mentioned in the book. This is what we're finding that happens. Birds seem to be attracted by the droning sound of these propeller blades as they turn. And because of that, they will fly into the path of where the wind farm is, and birds have been sliced up and cut and harmed by the blades of a wind turbine. So that's a serious consideration, especially along California's coast, for instance. Just like we have a lot of migrating birds from Canada, you know, that make their way down here on their way to South America, we also have the same situation coming from Canada and coming along the California coast. So we have learned from these different yellow dots that are here, we have learned that there's an increase in destruction of birds and bats. Flying organisms seem to be attracted to the droning sound of these windmills. This is no joke, I'm serious. So birds are being killed by our wind farms. That's the big negatives. Positives are pretty darn good. High net energy, very efficient, doesn't cost too much to build a wind farm. I mean, you have to spend the money for the turbine, obviously. That looks like it's expensive. But relatively low environmental impact, except for what I talked about over here. No emissions whatsoever. Easy to put up, easy to add more. And then here's the point I was making a few minutes ago. The land below the turbines could be used to grow crops or graze livestock, and that helps to mitigate the problem of the high land use. All right, I think that's wind power. Is there anything else here on wind? Thinking not. We've got 2 more videos to go for this chapter. We'll talk about hydrogen, and then we'll talk about energy future. What we think will happen in your lifetime concerning both gasoline, the energy that we need for transportation, and for electricity. Let me make sure that that's it. It is it. We'll talk about hybrid cars, electric cars, and hydrogen fuel in the next video.